This is the circuit diagram of a flip-flop using 2 push buttons. At first glance, it may look a bit confusing, so let's analyze it step by step. First, this is the transistor on the left, which controls LED D1. When power is first applied, the transistor does not conduct, so the current cannot flow through. At this moment, the voltage at the collector pin is about 5 volts. Next, observe the path to the base. When current flows through base and emitter, the transistor begins to conduct. At that point, the LED turns on, and the voltage at the collector of transistor Q1 drops to about 0.4 volts. The transistor on the right, which controls LED D2, works in the same way. The key point to note is the voltage at the collector of each transistor is fed into the base of the other transistor. This cross-coupling is what keeps the 2 transistors always in opposite states. Now, let's consider both sides at the same time. When power is first applied, both transistors tend to conduct. But in practice, because component characteristics are never exactly identical, one transistor will conduct slightly faster. Suppose that transistor turns on first, then its collector voltage will be pulled down to about 0.4 volts. At that moment, the voltage fed into the base of the other transistor is not enough to keep it conducting, and that transistor will completely turn off. As a result, only one LED lights up while the other stays off. This is the basic principle that allows the flip-flop circuit to maintain a stable state. Now we press the left button. At this moment, the current supplied to the base of transistor Q1 is pulled directly to ground, causing Q1 to stop conducting. The voltage at the collector of Q1 rises to nearly 5 volts. This voltage is fed into the base of transistor Q2, making Q2 conduct, and LED 2 lights up. Similarly, when the right button is pressed, Q2 stops conducting, the collector of Q2 rises to 5 volts, which drives Q1 to conduct again, and LED 1 turns on. This is the operating principle of the flip-flop circuit with 2 push buttons. So, we have just explored and practiced a simple flip-flop circuit with 2 push buttons using transistors. This circuit clearly demonstrates the principle of state retention. Only one LED is on at a time, and the state can be switched by pressing a button. I hope that through this video, you now understand more about how a flip-flop works and the basic application of transistors in digital circuits. In the next video, I will show you how to design a flip-flop circuit using only one push button, much more interesting. Thank you for watching. Don't forget to hit like, share, and subscribe to catch my upcoming videos.